Hello everyone. Today I want to take you through our process, how we can predict Airbnb rental price using machine learning. This process involves collecting data, cleaning and processing it, engineering new features, training a predictive model, and evaluate its performance. By the end of our talk, you will have a clear understanding of how data and artificial intelligence come together to make useful prediction in the real world. Let's begin with our first step, data collection. To build a prediction model, we need a data set containing information about Airbnb listing. In this case, we extract data from a CSV file that includes various detail about each listing, such as the listing name, host detail, location, type of accommodation, price, availability, and reviews. Once the data is loaded, we inspect it using functions that help us understand its structure, detect missing value, and summarize key statistics. However, raw data is really perfect. That's why we have our second step, data pre-processing. This involves cleaning the data set by handling missing values, removing unnecessary columns, and standardizing the format. For example, some listing might be missing host name or review counts, so we either fill in missing value with appropriate estimates or drop irrelevant columns. Additionally, we categorize and encode textual data such as neighborhood and room type so that our model can understand them. To ensure the model learns effectively, we also scale numerical values like price and availability so that no single feature dominates the predictions. Finally, we split the data set into two parts, 80% for training the model and 20% for validating its accuracy.
Once the data is clean and structured, we move on to feature engineering, which involves creating new attributes to improve the model's accuracy. In this project, we introduced two new features, host density and demand score. Host density measures the number of listing per host, helping to identify whether a listing belongs to an individual or business. A demand score, on the other hand, combines factors like availability and review frequency to estimate how popular a listing is. Additionally, we transform latitude and longitude to coordinates into bins, making it easier for the model to recognize location-based price patterns. Now comes the most exciting part, training the model. Um, we use a deep learning approach, specifically a new neural network built with TensorFlow and Keras. And this model consists of multiple layers that process data and detect patterns, allowing it to predict rental prices based on various factors. To ensure accuracy and efficiency, we incorporate activation functions and dropout layers to prevent overfitting and the animal optimizer to fine-tune the learning process. The model is trained over 100 cycles, known as APCOs, during which it continuously refines its predictions. However, to avoid unnecessary training and save computing resources, we use an early stopping mechanism that halts training once the model reaches peak performance. After training, we move on to model evaluation to measure how well our model performs. We use three key metrics, MAE, MSE, and R squared. MAE calculates every difference between predicted and actual prices, which in our case is about $60, meaning the model's price estimates are usually within $60 of the real value. Uh, MSE is another way of assessing errors, but it penalizes larger mistakes more heavily. Finally, the R-squared score tells how much of the price variation is explained by our model, helping us gauge its overall effectiveness. And once the model is trained and evaluated, the final step is making prediction on new listings. We take our test data set, apply the same pre-processing steps, and feed it into the trained model. The model then predicts rental prices for each listing, and we save these predictions in a CSV files called submit.csv. The file can be used for further analysis as a part of larger decision-making system for Airbnb hosts and renters. That's all. Thank you.